So let's talk about the Coriolis effect. Here I have a model made using a basketball, but before I get to my model, let's describe what the Coriolis effect is. So the Coriolis effect is basically what happens. It's basically the deflection of an object's path due to the rotation of Earth. So for example, let's look at this model here. I have the North Pole, I have the South Pole, and I have the Haley cell right here. So now imagine if we were to throw a ball straight down from the North Pole to the South Pole, and if Earth wasn't rotating at all, then the ball would just go straight down in a straight path. However, that is not the case because Earth is rotating to the east. It's rotating to the east. So the path will be deflected. Now, the deflection of the object moving north or south is because planets' surface tend to move much closer towards the equator than at higher latitudes. And that is because toward the equator, it has to complete a revolution that has such a longer circumference than the revolution over here or here or down here. So that is why Earth rotates much faster near the equator. So now let's imagine the polar cell at the North Pole. The polar cell moves the air away from the North Pole towards the 60-degree latitude. Now, if Earth wasn't rotating, the wind path would actually be going straight down. However, that is not the case because Earth is rotating to the east, and it is rotating much faster as we get closer to the equator. So due to that, when the wind coming from the North Pole will be deflected to the west, since Earth is rotating so much faster at 60-degree latitude than at 90-degree latitude and is moving to the east. So as the wind goes down, it will actually be deflected to the west right here. And that is the same thing with the South Pole. So also with the Haley cell, when air sinks to Earth's surface at approximately 30-degree latitude, it is supposed to go straight down. As you can see, this wind path is supposed to go straight down towards the equator right here. However, it is not going straight down because the Earth is rotating. And since Earth is rotating much faster at the equator, the wind path will also be deflected to the west because the Earth is rotating to the east. And it is rotating so much faster at the equator that as the wind starts to drop down, it will be deflected in the opposite direction to the west. And basically, that is how the Coriolis effect works.